Okay, Assalamualaikum. Salam sejahtera for experiment 5, home-based experiment. Okay, it is chemical equilibrium. We want to study the effect of concentration, temperature and pressure on chemical equilibrium. So, in this experiment, we use carbonated drink. Okay, carbonated drink are made by forcing carbon dioxide gas into the drink under high pressure. Okay, the process is called carbonation. Here where we force CO2 gas into the solution. So what we have is CO2 in gas. Okay, dia akan melarut dalam air forming CO2 in aqueous plus heat because the reaction is exothermic. Okay, the reaction release heat. Okay, after CO2 has dissolved into the solution, it can then react with H2O. Okay, forming carbonic acid H2SO3. Okay, carbonic acid can dissociate into its ion H plus and HCO3 minus. Okay, so now we have a system where the system is our carbonated drink. Inside the system, we have all these three equations, all these three reactions. Okay, so at one point, the system will achieve equilibrium. Okay, equilibrium means that the system is stable. So for example, if I have a polyplasticine, okay, I make a perfect circle, plasticine ball. Okay, so I can say that the ball is in equilibrium because it is perfect. It is stable. So if I pinch the ball, okay, what the system will do is that it will resist the changes. It want to get back to the perfect circle. So it is the same for the carbonated drink. If the drink is already at equilibrium, so if I make any changes onto the system will minimize the change that I made. Okay. Okay, so in this experiment, we change three things. First, temperature, and then concentration, and then the pressure of the carbonated drink, which already in equilibrium. So let's see what happened. We will observe the changes. We will observe the effect in terms of bubble gas release. Okay, for part A. Okay, we have two bottle A and bottle B. Before we introduce any changes in temperature, we observe the bubble. Okay, shake the bottle a little bit and we can see that bubble gas released. Okay, or you can be specific by putting the color of the bubble gas, colorless bubble gas released. It is the same observation we can see for bottle B. Before we introduce any changes in temperature, okay, we can see colorless bubble gas release. Okay, but for bottle A, we place the bottle in cold condition in a beaker filled with ice for 5 minutes. And then after 5 minutes, we shake the bottle again. We can see that less colorless bubble gas release. Okay. While for bottle B, where we put the bottle in a beaker filled with boiling water, after 5 minutes, we can see that more colorless bubble gas release after 5 minutes. So what happened? Okay. You are asked to discuss the observation in bottle B. Okay, why we have more bubble gas release uh, when we put the carbonated drink in solution of boiling water. Okay, so what happened there is that we increase the temperature for bottle B. Okay, so okay, we have to refer to the first equation. Okay, For bottle B, after we put the bottle in the beaker filled with boiling water, that means the heat increase. Okay, so we say that the system, the carbonated drink, is in equilibrium. So when I make a change, the system will resist the changes. Okay, so the disturbance that I introduce is increasing temperature. Okay, this is what I make, and what the system, how the system will react is it want to decrease the temperature. Okay, so how to decrease the temperature? It will have to go to the left side. Okay, it means that CO2 and aqueous, CO2 in aqueous and heat uses heat to form CO2 in gas. Okay, so the system will shift to the left. It will use heat to form CO2 in gas. So by using heat, that means that the temperature will decrease. So if you are confused on the shift, whether it will shift to the left or to the right, so just see in the equation which side is higher. Okay, in this case, heat is on the right side. Okay, we increase the heat, so this side is higher compared to this side. Okay, so like a slide, it will slide down from the higher part to the lower part. Okay, so it will slide down, in this case, to the left side because this side is higher. So that means that the shift is to the left. Okay, so again we see that it will shift to the left, so it will form CO2 in gas. So that's why the observation here is more colorless bubble gas produced. Okay, because we are forming CO2 in gas. Okay, so you have to turn all that into sentences and include that in your observation, in your discussion. Okay, and then for the part B, the effect of concentration, in this part, we add vinegar. Okay, so before we add the vinegar, we first observe the bubble gas produced. Okay, we shake a little bit, and we can see that colorless bubble gas produced. Okay, and then we introduce the effect of concentration by adding vinegar into the carbonated drink. Okay, after adding the vinegar, we again observe the bubble gas. Okay, shake the bottle again, and we can see that more bubble gas produced after adding the vinegar. Okay, so you are asked to discuss the effect of vinegar. Use the equation stated in the introduction to explain why adding vinegar or lime juice to your carbonated drink may cause it to taste slightly flat. Bila tambah vinegar tu dia dah tak rasa fizzy tu lagi. Kenapa? Because the fizzy things or the CO2 in gas has escaped. The observation here, more bubble gas produced. So the things that produce fizzy taste has escaped the carbonated drink. So what's left is a flat taste. Okay, why? Why more bubble gas is produced? Okay, we can refer to this equation. Okay, here H plus. Okay, the vinegar or the lime juice or the lemon juice that we add increase the concentration of H plus. Okay, when this side increase, okay, The disturbance that we introduce is the increase in the concentration of H plus. Okay, so the system will want to decrease back the concentration of H plus. Okay, so this side is higher, this side is lower, so it will slide down to the left. Okay, what happened that is that we will produce carbonic acid. Okay, we have high concentration of this thing. Okay, and then it will affect the second equation. When we have high concentration of carbonic acid, okay, oh, okay, again this side is higher, this left hand side is lower in quantity. Okay, again we can see the shift. It will slide down to the left, it will shift to the left. Okay, so we have a reverse equation going on. It will produce CO2 in aqueous. And again, this will affect the next equation, the first one. Okay. In the second equation, we have shift to the left, forming CO2 in aqueous, meaning that the concentration of CO2 in aqueous is high. So for the first equation, when CO2 in aqueous is high, okay, again, we can have a shift to the left because this side is higher than the left hand side. It will shift to the left, okay, forming CO2 in gas. So all that at the end will causes shifting to the left in the first equation. So the shift here is to the left hand side. For me, it will form CO2 in gas. Okay, so that's why after we add vinegar or lime juice, we can see we observe more bubble gas produced. Okay, because adding vinegar or lime juice increase the concentration of H plus, the system will react to minimize the changes, the effect. It will want to decrease the concentration of H plus by shifting the equation, the first, the third, the second, and also the first one to the left. Okay, and the effect is that more CO2 gas is formed. Okay, more CO2 gas is released and leaving the carbonated drink feeling flat, taste flat. Okay, and then for the last one is the effect of pressure. Okay, in this part, we shake the bottle a little bit. Okay, observe the observation before we introduce any changes. So like before, we can see colorless bubble gas produced. Okay, and then place the carbonated drink in a glass. Okay, with white mouth, white glass. Okay, after putting that in the glass, okay, observe the bubble gas. Okay, we can see that in the glass, more bubble gas produced. Okay, dalam botol bubble gas sikit je ada bila kita masukkan dalam gelas. Okay, kita nampak dalam gelas ni lebih banyak bubble gas terhasil. Why? Okay, inside the carbonated drinks bottle, inside the bottle, the pressure is high. After we transfer it into a glass, okay, in a glass, the pressure has decreased. Okay, so it is the first equation. Okay, the disturbance that we introduce is the decrease in pressure. Sebab dalam gelas pressure dia kurang. Dalam botol, boleh bayangkanlah dia bekas yang tertutup. pressure is seal. Pressure dalam tu kekal, tak ada yang boleh escape, tak ada gas yang boleh escape. Tapi when we introduce the carbonated drink into a glass, okay, a glass bekas yang terbuka, the pressure drop, pressure berkurang. Okay, so the system will want to increase the pressure again. Okay, so we have to refer to the first equation, which side has higher pressure. Okay, for pressure, we only look at the molecule that is in gaseous phase. Okay, ini fasa gas. Okay, kita tengok. Ini fasa aqueous, kita abaikan because aqueous doesn't produce any pressure. Okay, heat juga tak contribute to any pressure. So you can see on the left hand side we have 1 mole of gas, while on the right hand side we have 0 mole of gas. Okay, so remember that the system want to increase the pressure, so it will shift to the left because by shifting to the left, it will produce 1 mole of gas. Okay, when it produce gas, more gas, okay, it can increase the pressure. Itulah yang dia nak increase the pressure. Okay, so the shift here is to the left. Okay, by shifting to the left, it will produce CO2 in gas. So that's why we observe more bubble gas produced. Okay, when we put the drink in a glass. Okay, explain what will happen if the carbonated drink bottle cap is open for a long time. Sama juga macam kita pindahkan air tu ke dalam gelas. Kalau kita buka dia punya cap for a long time, kita buka, okay, the pressure release. So means that apa effect yang kita dah buat, apa disturbance yang kita dah buat, kita dah turunkan pressure. So the system will want to increase the pressure back. It will shift to the left. Okay, because by shifting to the left, it will produce CO2. Okay, by producing CO2, the system will increase the pressure again. Okay, itu je. I hope that you can turn all that your understanding into a complete sentences and complete your lab report. Okay, thank you.